Have you ever wondered why we dream? What purpose does it serve in our lives? Dreams, those elusive specters of the night, have piqued human curiosity since time immemorial. They've been the subject of countless works of art, literature, and philosophy, and yet they remain an enigma, a puzzle waiting to be solved. As we delve deeper into the 21st century, dreams are no longer just the domain of poets and philosophers, but also of scientists and psychologists. The question of why we dream has shifted from the realm of the metaphysical to the empirical, and we're beginning to unravel the intricate tapestry of dreams through the lens of science. Are dreams merely the random firing of neurons during our sleep, or do they serve a deeper, more profound purpose? What does current scientific research have to say about this fascinating phenomenon? Let's dive into the fascinating world of dreams and uncover the science behind them. Dreams are not just random images playing in our mind, there's a whole scientific process behind it. To comprehend this process, we need to understand the different stages of sleep and the role our brain plays in dreaming. Sleep is a complex phenomenon that unfolds in 5 stages. The first 4 stages are part of what's known as non-REM sleep, while the 5th stage is characterized by rapid eye movement, or REM sleep. The initial stages of sleep are relatively light. As we drift off to sleep, we enter stage 1, a transition period between wakefulness and sleep. Stage 2 is a slightly deeper sleep, and stages 3 and 4 are deep sleep stages, when the body does most of its healing and repairing. But it's the final stage, the REM stage, where the magic happens. This is the stage where the majority of dreams occur. REM sleep is characterized by quick, random movements of the eyes, increased respiration rate, and temporary muscle paralysis. Now, let's delve into the role of the brain in dreaming. The brain is a complex organ, and different parts play different roles in the formation of dreams. One key player in this process is the limbic system, a group of structures in the brain that deal with emotions, memories, and arousal or stimulation. Within the limbic system, we have the amygdala and the hippocampus. The amygdala is responsible for processing emotions, and it's particularly active during REM sleep. It's this activity that gives our dreams their emotional intensity. Then we have the hippocampus, the guardian of our memories. It plays a crucial role in consolidating information from short-term memory to long-term memory. During REM sleep, the hippocampus becomes active, and it's thought this activity plays a part in the narrative structure of our dreams. So the process of dreaming is not as random as it might seem. It's a carefully orchestrated event, driven by various stages of sleep and the intricate workings of our brain. So, while you're peacefully sleeping, your brain is working hard, creating these intricate dream scenarios. Our dreams are not just a result of our brain activity but also the interplay of various chemicals. This chemical alchemy is what fuels the fantastical world of our dreams. Central to this process are 2 key neurotransmitters, serotonin and norepinephrine. Serotonin, often referred to as the feel-good hormone, plays a significant role in regulating our mood, appetite, and sleep. It's no surprise then that it's also intimately involved in our dreams. Serotonin levels rise and fall during our sleep cycle, influencing the emotional tone of our dreams. Meanwhile, norepinephrine, a hormone and neurotransmitter associated with the body's fight or flight response, also has a role to play. It affects our emotional intensity during dreams, turning mundane scenarios into thrilling escapades or terrifying nightmares. So the next time you wake up from a dream that had you soaring through the sky or running from a monster, remember, the chemical reactions in our brain are the unsung heroes behind our most vivid dreams. So, to sum up, dreaming is a complex process involving various stages of sleep, brain activity, and chemical interactions. Let's take a moment to recap what we've learned so far. Dreams are more than just figments of our imagination. They are the product of intricate processes within our brain, and they occur in a distinct cycle that correlates with our sleep stages. In the first stage of sleep, the transition phase, our brain activity slows down, but we can still be easily awakened. Dreams in this phase are usually brief and vague. As we transition into the second stage, our brain waves become slower and our body temperature drops. It's in this stage that we spend most of our sleep, but it's not where the most vivid dreams occur. The real magic happens in the rapid eye movement or REM stage. This is when our brain activity spikes, resembling the patterns of when we're awake. It's in this stage that we experience our most vivid and memorable dreams. Our brain is buzzing with activity, and yet, our bodies are in a state of paralysis, a phenomenon known as REM atonia. This is nature's way of protecting us from acting out our dreams and potentially causing harm to ourselves or others. But what about the content of our dreams? While there's still much to learn in this area, science suggests that our dreams are influenced by our daily experiences, emotions, and even our subconscious thoughts. They are a mix of reality and fantasy, often guided by our deepest fears and desires. And let's not forget the role of neurochemicals in our dreams. During REM sleep, our brain is flooded with a cocktail of chemicals including acetylcholine, which boosts brain activity, and serotonin, which regulates our mood. These chemicals play a crucial role in shaping the content and intensity of our dreams. So the next time you wake up from a dream, remember, it's not just a dream, it's a neurochemical masterpiece.